Okay, up and now. Hey, Sandy, you want to run with the minutes? Or Jeffrey?
I have a presentation, two presentations.
Okay, true.
Is Sandy here?
Yeah, but she's online. Maybe hard for her.
The minutes taker. Okay.
Yeah, the problem if I open the minutes tool, I don't see anything else, so that doesn't work particularly well. And I can get into the stuff twice. Is there any kind of a trick for the whole thing that is not very well thought out? Open a new tab. Okay, yeah, they have something. All right.
Good. So I think it's time to start. We are on time. So topic is 112, so we need to change the topic, which I'll do soon. So welcome to beer session at IETF113. Tony P. Jr. So I'm the delegate, and let's just start. Tony P. is going to talk about what's going on and provide an update.
All right, so you're sharing the slides, Jeff, right?
Yep. And you can show up your face as well, so we remember how you look like.
Nah, my office is too messy. Okay, the usual note. Well, I think we've seen that in every group about 1,000,000 times, so I won't, chew through that stuff unless Jeff wants to go once over it again.
So please read not well. It defines how your contributions to IETF are treated, and before you start contributing to IETF, you really should know what not well said.
All right. Yeah. Yeah, no, the meter echo is good. Yeah, buttons are changing. It's getting better and better.
So if you participate in person, please check in so your name gets on blue sheet. If you want to talk at the mic, please get in line throughout the tool and then come to the mic. And don't forget to state your name. For remote participant, don't forget to turn video and audio off unless you're going to speak. And yeah. So minutes are at the URL provided. Please make sure that whatever you say is correct, and please fix stuff if you see it's wrong. Tony.
Yeah, sorry, since I have to take minutes, I'll be also typing. All right. So agenda simple. We do the status, then we have small preso. Jeffrey, this is the stuff that was non-ether, now it calls non-MPLS. So this is all the stuff that we need to encode in non-MPLS case. Then let's talk about the IOAM stuff that was suggested in basically OAM in general, pluses, minuses, because there's a couple of proposals being tossed around. Then the beer FRR stuff comes up again, I see. Actually, I'm lost. Why is that on the agenda? Okay, I'm kind of I lost it here. Then we talk about the beer RH beer stuff, I guess, again, if there is anything to be talked about. And then we do the general delivery function, which stuff is interesting, especially with all the OEM suggestions and fragmentation coming up with, goes across multiple different technologies. All right. So we fire off the status. All right, so the beer bar IPA, I think Jeffrey closed all the comments. It's on Alvaro. PIM signal is waiting for a document to be referenced. The TE architecture is kind of all sewed up. I saw everything has been addressed pretty much. The OSP B3 is hanging in publication. Next one, please. All right. So yeah, that is the Ethernet goes into non-MPLS. Jeffrey will be talking about the stuff. Next one. Right. So the pattern queue discovery is waiting for write-up, and ping is also waiting for the write-up. So I assume there will be some kicking needed. Okay. The BGPLS BIER is expired. IDR didn't react. The IDR extensions, the draft has been expired, so we have to go and look for authors again or rewrite the stuff. And the multicast HTTP response, yeah, sorry. So exactly. So that the draft is being replaced as a presentation today. Sorry, that's where I got lost because I still have it on the multicast HTTP response. The BIER-FRR has been merged. Everything is kind of ready. There is one mailing list issue stuff. Oh yeah, I should probably talk about the Git quickly, which would need to be addressed for the adoption. I think it has been brought up during the adoption call. Multicast as a service will be presented today. We'll see what the author calls for adoption. I will work the queue over once we throw the status. Next one, please. All right, so that's kind of the status. Jeffrey, you have the mic.
Yes, the our IPA drafts. Thanks for Alvaro to review it, and we had quite some rounds to discuss what's the best language there. I yet need to do one more revision. I haven't got that done yet. Should be simple change, and then you should be able to go forward. So about the multicast as a service. Well, I'm not presenting it today, but indeed it was presented before, and we wanted to do an adoption call. By that time, there were a lot of drafts to be called, and so I was told that we would pace out, and I think now it's time to do it now. But I'm not presenting it today. I think that's about it from me.
Okay, so I take that stuff as adoption call going to the list for the BIER's multicast as a service. Okay, thanks for the correction on the IDR. Okay, please state name and affiliation when coming up to the mic. It will help the people online. Alvaro, you have the mic.
Alvaro Rotana, Rolling AD. So I want to, the deck is not there anymore, but I want to go back to the BIER Factory Route draft. I noticed there have been several requests from the authors on the list to adopt, and I hadn't seen, maybe I missed it in the last couple of days, I hadn't seen any reply on what are the open issues. Now I see here that there's a link to the GitHub.
Yes, sorry. So yes, Andrew actually suggested that we have some kind of a repository where we can have a history per draft of all the issues that have been addressed and what is outstanding. And we went back with Greg back and forth and with the secretary, and we decided that the best approach will be basically to go onto GitHub because of the history requirements, right? That the tracker doesn't allow us to really have a history of stuff that was going on. So the best format seems to be to get on the GitHub and have a Git per draft, and on this draft we will keep basically a running document. We'll be committing into Git. Because that will give us a perfect history how the stuff is developing.
Sure. So I don't have a problem with that. So what I wanted to do is highlight 2 points. One is the lack of response on the list. That if you already replied, then that's great.
So yes, Sandy replied actually with that stuff because we were converging the thing. What should we do? How should we reply? And we decided that we generate this Git. Yeah,
that's fine. The other thing that we need you to do is figure out as a working group how you're going to use GitHub. It's fine if you want to. And there are many things you can do with GitHub, right? You can do everything from the development of the draft. You can just track issues. How are the issues that are being discussed in GitHub going to be reflected to the list or not? Is everyone expected to go get an account on GitHub and follow the issues there? Yeah. Is that going to happen only for drafts that are adopted? or not. This one is not adopted, of course, yet. So, there needs to be a policy for the working group that is clear and everyone knows about it. There's a couple of drafts that the Git working group produced last year on recommendations on how to do all this, right? Not only how to set up the repository, which you already did, which is great, but also on the different decision points that need to be made, right? Because whatever issues are discussed on GitHub are not automatically reflected on the list, right?
Yeah, unfortunately.
Right, and there's the note well issue and all that other stuff. So please take a look at the Git RFCs.
Yes.
I forget the numbers, and it provides there a list of things to consider.
Yeah, don't worry. We'll find that stuff. So I take it up as action item on the chairs. Yeah, I think you pointed us already to this Git working group, and then we kind of went off and started to think how we deal with the stuff, with the history issues. It is unfortunate that the tracker does not allow, to keep the issues per draft and the history. That would be a good suggestion, because that starts to become, more and more of a pressing issue, since mailing lists are just simply too, far flung to expect everyone to be up to date on all the threats and all the stuff that has been raised. So okay, action item with the chairs. Let us converge on the stuff and fire off something to the list with kind of a official policy. I mean, we don't want to make it too much red tape, but something that is based on the Git working group recommendation and how we roll the stuff forward. Okay, good. Yes. Thanks. Wymo, you have the mic. Wymo?
Wymo, you need to unmute.
Yeah, unfortunately, I cannot unmute him.
I mean, he needs to do it. Actually, I don't see any mic. So let's move to the next presentation, and when he figures out, Jeffrey.
Okay, so this is updates on this non-MPO extension on behalf of the co-authors. Next slide, please. It's got quite some history. Back in 2018, we have this initial version. The name is non-MPOS extensions. You can notice the non-MPOS keyword there, but at that time, the scope was Ethernet only. And because of that, 3 months later, we renamed it to Ethernet extensions to reflect that scope of Ethernet only. And then later on, I raised the question, why should we limit to Ethernet only? There is no reason to limit that. It should work for all situations. But the work has stalled since then, besides the working group adoption. Finally, we recently confirmed that original editors could no longer work on this. So I took the pen and then published this new version with the non-MPO extension, because we have not heard a good reasons to not to do so. But we can still discuss it, whether this is a good thing. So far, I've only seen good reasons to make it generically non-MPOS. Next slide, please. Since it's been there for quite a while, so I thought I'll just go through the content very quickly. The first big topic here is BIF ID in case of non-MPOS encapsulation. The encapsulation RFC says that for non-MPOS, the BIF IDs, they are domain-wide unique. In case of MPOS, BIF IDs are just labels, so they are locally significant. But when it comes to non-MPOS, they are domain-wide unique according to the encapsulation RFC. And There are two ways to specify those BIFs, but the BIF IDs, according to that draft IETF BIER non-MPOS BIF encoding. The first one is basically just hard encoding, bit string length, subdomain ID, and set ID as BIF ID. And when you do that, there's no need for provisioning or signaling. But that does not give you any flexibility that MPOS way gives. To retain some of the flexibility, then a second way to do that is that instead of hard encoding the BSL and subdomain ID, we hard encode a 16-bit IBU. I forgot what IBU stands for, but basically just an opaque number. It can be anything. To do that, then we would need IBU to be provisioned on each router. Now notice that BIER architecture RFC 8279 actually does not mandate domain-wide unique BIF IDs. So in another draft, it was argued that even for non-MPOS, BIF IDs can be like MPOS labels. And if you do that, you do not need to have any provisioning, and you still have the flexibility that MPOS way provides you. So if you go that way, then the BIF IDs, even for non-MPOS case, they are just 20-bit opaque numbers, except they are not called labels. They're like MPOS labels, are not called labels. They can be locally assigned independently. Of course, they can also be coordinated across all the routers. And when you do the coordination, then the consistent values can be used, just like in the segment routing SRLB and SRGB labels is very similar. Next slide, please. So in this document, we want to take the approach that you can either use the two approaches specified in that non-MPOS BIF encoding spec, or we can signal the BIF IDs that can be local or domain-wide unique, just like how we do it with MPOS. So that's one main topic in this document. Next slide, please. So next part is exactly how we do signaling. ISIS, OSPV2, OSPV3, basically they will be extended to signal dynamic and local non-label BIF IDs, and it mirrors the way we do it for MPOS. So in the bottom, there are two figures there. The first one is the BIER information TLV that is already specified in the MPOS signaling, and that remains. That TLV has some sub-TLVs that in case of MPOS, they will specify MPOS encapsulation, and it will signal the label basis. Now we will just mirror that. We have a new sub-TLV to signal the non-MPOS encapsulation with the BIF IDs. You can see that if you replace the BIF ID with label, then it will be identical as in the MPOS case. Next slide. So we talked about the two main topics in the draft, and now changes in the latest revision. The first is the name and scope change. It's called non-MPOS BIER extension. It can work with any scenario, whether it's BIER following the Ethernet header, or follow any tunnel header, or IPv6, whatever. Editorial changes, and finally there is one change. It's about linking between areas or levels. Next slide, please. So I have an example topology here. OSPF example where one area on the left, another area on the right, BFER12 and BFER34. Now, if you look at the BFR4 and 5 in the right, now when it comes to for BIER purposes, the BFRs or BFERs on another area on the left side, they don't care about BFR 4 or 5 at all. They care about BFER 3 and 4 only to the extent that they care about those BFER 3 and 4's subdomain topology, bar IPA value, and the BFER IDs. But they don't care what encapsulation that BFER 3 and 4 uses, because routers in the left area only cares about that, oh, I can get to BFER 3 and 4 through BFR 3. So as long as I know that, and then as long as I know what encapsulation I should use to get to BFR 3, they should be all set. So because of that, when we leak the routes into across areas or across levels, then for BIER information TLV, if it does not have a BFR non-zero BFR ID, then that information does not need to be leaked at all. Of course, you can leak it. It's of no use. So we say that you may skip, you may omit the BIER or info TLV along with its sub TLVs if the BFR ID is 0. And then you may also omit the encapsulation TLV, sub TLV, even if you do leak the BIER info TLV. Next slide, please. So comments. I want to mention that we had a working group last call before on the IDR extension and also BGPLS extension. At that time, I commented that we should wait until this draft settles, because this draft originally was talking about Ethernet only, but IDR and BGPLS, they were talking about non-Npos. So we should be consistent. Now, if we agree that we're now settled on this one, then at least my earlier comments on those two drafts, they are no longer there. We believe it's ready for working group last call. I did have some discussion with Jinrong offline on whether we want to use the locally significant BIF IDs. So I added those slides for this today to call that out, to show why we want to do that. I hope we have reached that consensus, but we'll see. So that's it.
Thanks, Jeffrey. Any comments?
Yeah, Tony. So what's the consensus on the local significant BIF IDs? I didn't see this discussion going on. You want to do translation between domain when you're leaking, or what's the deal?
It's not translation. It's you don't need that information basically.
Okay, because I mean the border gateway will do the decision anyway, right? Stitch the stuff.
Right.
Yeah, it went leaking. Yeah, okay. So that's why I was confused why you even had the discussion. Good, thanks.
Oh, the discussion is actually not about discussion. Is about whether we want to signal the BIF IDs at all, because there is already a working group draft talking about domain-wide unique BIF IDs that does not need signaling at all.
Yeah, of course. Yes.
Yeah.
So the discussion was whether we need both variants or whether we keep the globally one that is basically computed.
Both they are all okay. I mean, the operator can choose which way to go.
Right. But if you don't compute them predictably, then you need to signal them, don't you, within the domain?
Correct. If you
Okay,
don't use
yeah.
the unique one, then you need to signal.
Okay, fine. Yeah, thanks.
Okay, I see no more question. We'll move to Beer IOM presentation.
Hi, everyone. It's Xiaoming speaking. This presentation is on beer encapsulation for IOM data. This chapter was presented at IETF 108. This is the second time it's presented. Next slide, please. Firstly, recap on the intention of this draft. This draft provides the encapsulation for IOM over beer. This draft describes two options of encapsulation. Option 1 is beer header plus beer OAM header plus IOM header plus payload. Option 2 is beer header plus IOM header plus payload. Among these two options, option 2 is selected as the standardized one because it's a more concise and commonly used encapsulation method. Just last weekend, we noticed there's a third option, which I assume is beer header plus GDF header plus IOM header plus payload. Next slide, please. Here is the IOM relevant status update. All IOM options except direct exporting IOM option are defined in draft IETF IBPM IOM data, which is currently in RFC editor queue. The direct exporting IOM option is defined in draft IETF IBPM IOM direct export, which has passed the working group last call in IBPM working group. IOM over IPv6 encapsulation is defined in draft IETF IBPM IOM IPv6 options, which has also passed the working group last call in IBPM working group. Next slide, please. This draft outlines some requirements on IOM over beer. Some multicast flows, such as live video and real-time meeting, are sensitive to packet loss, delay, and other factors. Nicely, a in-situ OAM provides a way to achieve on-pass telemetry information collection, which is necessary for the beer multicast network operator. Next slide, please. This slide illustrates the IOM over beer encapsulation. The IOM data is immediately following the beer header. It's indicated by beer proto. The IOM data contains one or multiple IOM options, and each IOM option contains IOM type, IOM header length, next protocol, and IOM option data. Next protocol field in each IOM option follows the definition of beer proto field. When multiple IOM options are present, the next protocol field in all IOM options except the last one is set to indicate the next IOM option. And the next protocol field in the last IOM option is set to indicate the type of payload. With this encapsulation, IANA is requested to assign a new beer prototype for IOM. Next slide, please. The authors believe this draft is ready for working group adoption. However, there was a bigger picture GDF brought up to our attention last weekend.
Yeah.
Sorry.
Yeah, please finish. Please finish.
I admit I didn't follow the evolution of GDF closely, so I think I need more time to learn the advantages of GDF, if there's any. Thank you.
Okay, so let's have a vivid discussion because I thought that the mailing list fired up in a very productive way, right? And I think I would like opinion on two axes here. The first one is there is obviously an advantage if we stick IOAM on the beer packet, right? Because it kind of measures the data path as it goes and not some artificial, OAM stream going. Now, the problem is, however, that the beer header will determine what is the destination of all this OAM information. And is it desirable that the OAM ends up on all the receivers? Or do we want to send basically an OAM operationally per receiver? Is that the more common case? Because that determines how useful the whole thing is. The second discussion point is here. The second axis is, no, that's the primary axis. And as observation to the presentation, I think the authors may have misunderstood how OAM is encoded in beer today. OAM is its own beer protocol, so the OAM packet does not carry a payload behind it. And Greg Mirsky will correct me if I'm wrong, but I think that was how OAM was intended. So it's in fact a separate stream from the real data stream. So I would encourage discussion along those lines. I think the work is extremely interesting. And then we can get to all the gritty detail, like whether we should fragment and GDF and assignments and so on. Thanks.
Okay.
All right, Jeffrey, mic is yours. So please state association and name every time.
Okay, Jeffrey or Zhao Hui from Juniper. So about how do we encapsulate the encoding the IOM data. Of the two options, one requires a beer extension header. I suggest that any discussion related to that extension header, we defer that to today, to the presentation, the last presentation today. Talks about exactly that topic. I'll have more details and information available as part of my presentation at the end.
Tinran? No, you're... Tinran?
I'm from Huawei.
Yep.
And I have showed my concerns and objection in the mailing list. There are already several IOM encapsulations, and I cannot find any advantage from this draft.
Okay, so I think the main objection was that the payloads carried in the beer packets, they have their own OAM. But now the question is, should we rely on that? That was not the beer architecture, right? Based on the requirements by providers, they wanted the OAM directly on the layer 2.5. Because if we start to stick IPv6 packets into beer and then assume that the IPv6 within beer does the OAM, That was something we didn't discuss out, but yes, that's also a thing that is a possible solution space data point. So I would defer this discussion to the list.
Greg?
I just want to point out that let's not assume that active OEM does not follow the same path as data flow, the beer flow that it monitors. So in terms of what is being monitored and measured, I don't see a difference whether we use IOM or active OEM.
Greg, so I quickly jump in. This is true to an extent. You cannot guarantee that the OEM is following the same queuing disciplines to the boxes, and OEM may have different packet sizes, which all affects delay, jitter, and other stuff.
Right, so, but at the same time, then if we use IAM trace options hub by hub, so the space for telemetry information either has to be pre-allocated by their ingress BFR or incrementally added by their BFRs as it transits. So
right.
that changes the packet, and that affects and skews the metric. So
right, and if the IOM causes fragmentation, then the whole thing will go to pieces anyway. Right, so those are interesting discussions.
Yes, okay. Thank you.
In this job, the beer IOM is defined as the upper layer of a beer header. I think it is the inner parameter for beer for BFR to handle the upper layer encapsulation of beer. Okay, thanks.
I have to admit I couldn't follow that really.
So I see now, please send your question to the list. Probably it's difficult to understand. Shao?
So the question from Tony, the second question. IOM is in situ. So the IOM header is with the packet, the data packet of the beer. So it's not just active OEM. So it's in situ OEM. It's with the packet, data packet. Secondly, I want to say currently we have already two adopted IOM encapsulation drafts. They are Iom over IPv6, Iom over SFC NSH. So I think Iom over beer is similar to these two encapsulations, especially IOM over NSH.
I would contradict that. Go look at all the supported beer protocol in the registry. For example, Ethernet and all kind of MPLS things. So you cannot rely on the fact that the payload will always have its own OEM. It's an interesting discussion, of course, right? But your point is that the payload carried by beer will always have an OEM is an assumption which will not hold up. Okay. But your argument,
let's take it to the list. Okay.
Okay, Robin.
Okay, can you hear me, Jeff? Hello?
Hello? We can
hear me?
Yep.
Okay. Zhenmin from Huawei. I have this following comments. First, in fact, I already explained my concern in the mailing list ever before. First, I means that the duplicate the IOM functionality, because MPRs has IOM, IPv6 has IOM, and also the beer is the independent layer. It also has IOM. If the beer over MPRs, beer over IPv6, there's the duplicate IOM, this functionality and the encapsulation. I think I don't know how to cope with this situation, the first one. The second one, because here is discuss about this IOM, but you know that now there's also the network slicing, and there's maybe also some the alternative marking encapsulation functionality that is IPv6 supported. I'm not sure if the slice for the beer or some this alternate marking for the beer, do we need to go on to extend or define this the extension header for the beer layer to support this functionality or not? The second one. The third one, I think that's if this IOM is defined for the beer layer. I think this is for the IPv6. They also have this the IPsec. And if the IPsec is used with the IPv6, so that's the beer header and also this the IOM header will encrypted. So I don't think how to encapsulate this information in the beer header if over IPv6 data plane. Okay, that's all my comments.
Jeffrey, you want to address the beer over v6 IPsec comment? Because the rest was basically all the same thing as Xiao, that the payload was already OAM.
Okay, Jeffrey from Juniper. In the IPv6 environment, the one option to do to the beer is that you do not need the IPv6 at all always. You can between the two adjacent BFRs, you could just be the beer header following the Ethernet header. So there, IPv6 does not apply at all. And even when we do need to use IPv6 tunnel between two BFRs that are not directly connected, at that time, the IOM information, which is specific, if it's specific to beer, then that should go along with the beer header itself instead of at the IPv6 level. That's how I see it, and I don't see how encapsulation plays a role here, because let's say you have encapsulation for the IPv6 tunnel, but that's fine, and because beer processing does not happen until you exit that IPv6 tunnel. So even if your IPv6 tunnel is encrypted, that's fine.
Yep, pretty much concurs with what I'm thinking. Thanks, Jeffrey.
And more generically, we've always had different IOM mechanisms at different layers because they have different semantics, potentially different speeds. So I don't see how having IOM in one layer would substitute for beer-specific IOM.
Yeah, well, that's why we have the MPLS ping and the other ping and overlay pings and everything going at the same time. Yep.
I also had this the last comments. I want to know that if the define the extension header, such as the IOM and also maybe later some the network slicing or maybe alternate marking or APN. So if this is in the charter of the beer working group or not. Because from my point of view, there's maybe more functionality to be defined.
You mean using basically kind of this shim in between, like IOM is using? Yeah, it's a good discussion. I have no answer. I think it's all a very interesting proposal to discuss through whether that makes sense to put a shim between the payload after the beer header.
I want to add, Jeffrey from Juniper, I want to add that in case of beer over MPLS, in most situations, there is no MPLS tunnel, and then the label is only to indicate that a beer header follows, and then this gives you the beef ID. So in that case, putting the beer IOM information as an MPLS extension header does not make sense either, and that's one point. Another thing is that if there is a reason to have a beer extension header, For example, for APM, for whatever purpose, for slicing, as long as you need a peer extension header, then let's defer that discussion to the end of today's session, where my presentation talks about that topic exactly.
If there are no more comments, I propose to take it to the list. It's a good discussion. Dirk?
Okay, the new deck is being shared. Hi, this is Dirk Rossen from Huawei. Talking about FRM. I realize there's one letter more than the FRR.
I don't see your presentation. That's weird.
Oh,
it's FRR, right?
FRM.
It's not here, right?
Oh, I had sent it though. Just look at maybe this one, the HTTP one. Let me see how it looks. That's the one.
Oh, yeah. Sorry.
Okay. Essentially, still labeled HTTP. So if you go to the next one, please. So this is a 0.0 draft, but there's some legacy to this draft. I just wanted to point out the draft originates from a now expired draft, which was in version 6 on multicast HTTP. It was very focused on, there was an applicability-oriented draft to realize HTTP-based scenarios in a beer environment. Must have been the order of 3.5 years old, I think. I still started that in my old company before joining Huawei. It was in Beer Working Group's last call. It returned very useful comments and feedbacks from the application areas. We had a couple of discussions around January time, etc., where we took this back to the original author set to see if there is an interest to continue on this, and there are organizational reasons why that didn't happen. So I was told by the author set there wouldn't be any interest to continue this, which is the reason for the 0.0 draft. So I restarted this because of the interest in the original draft. So I thought letting this drop would be a shame. So if you go to the next slide, please. So what I've done in this version now is to take the to generalize the draft. So it's been generalized towards a new communication semantic, which that's done in section 3, which now is applicable to use cases that are more than just HTTP. So we've turned an HTTP applicability draft into one that is tackling a communication semantic there. So there are more use cases being given. And then sections 5, 6, and 7, they are adapted from the original draft in order to support the more general semantics. So it's kind of like removing or replacing some of the HTTP terminology. Section 8 is meant to be a placeholder to incorporate the comments and discussions that were received from the app area that I mentioned that we discussed in January. It's still a placeholder, it's empty. I'm working currently on putting the pieces in there. If you go to the next slide, please. So very briefly, the core change is really to introduce this new semantic FRM, which stands for Forward Request Return Multicast semantic, which defines a very, which you could already see in the original draft, in the original HTTP draft, a multicast communication semantic is extremely flexible. So here a datagram with the source address S is towards the destination D1 to DN is formed as one or more responses to adequate requests from those destinations D1 requests that come in the forward direction to S, where the ephemeral group address R is defined through an identifying characteristic across all received requests. The identifying characteristic is an implementation specific parameter that's used to distinguish among different requests. If you translate it back from the old HTTP case, essentially the things like an HTTP URI was used in the HTTP applicability draft to differentiate requests. So if you have one set of requests coming into a single URI, you created a dynamic multicast response. If the URI was different, it created a different ephemeral group address. So this is the generalization of that idea. The nature of that multicast is inherently dynamic. So the multicast responses are formed in response to incoming requests. They may differ in extremely short timeframes, and the initial example of the HTTP case was showcasing that with over-the-top video, people are viewing the same thing, and you're starting to deliver the actual chunk request as multicast responses back to the actual clients. That was the idea there. Go to the next slide, please. So the next steps really here are to firm up some of the details, section 6 and 7, based on the FRM generalization to incorporate the comments from the list that we received into section 8. And obviously to incorporate any feedback comments from the list, on this work. And in particular, if you go to the last slide, it's the main question. This is a short presentation meant to be. Really answering the question, or getting an answer to the question from our side, if the work is still of relevance to this group. Is this something the group feels worthwhile to continue with a changed author set at the moment for the reasons mentioned? I would also like to understand more if this work is more widely applicable, even though section 6 and 7 in particular are being described with BIER in mind. Is this, given that it's talking about a general communication semantic, are there other underlay techniques that could be utilized for that? Any thoughts that anybody had, it would be very welcome. And obviously this was being put out rather quickly as a 0-0 with myself as the single author at the moment. I'm very much looking for other contributors to the work out there, in particular if the first question is positively answered, and maybe the second one as well. So willing to drive the draft forward. I would be very happy to hear anything of that. Thank you.
Okay, so if no one else is on the queue, I jump in. Tony, Juniper. Yes, that looks interesting, but it also looks like reliable multicast, generic reliable multicast, which is kind of, one of the famous red holes. If it can be solved, wonderful. Well, it's not the full reliable multicast, but, from one source to multiple destinations. No opinion whether we should, take on anything like that, whether it should be done in some other context. I think it very much depends on the interest within the group. So comment, please, if you're interested, in this kind of work, or you think that would make sense.
Maybe one short feedback on the reliable multicast. It isn't necessarily, as you already mentioned, it doesn't need to be reliable multicast. It really depends on some of the service invocation protocols we've been looking at there. They're not necessarily reliable, reliably transmitted. That may happen as well. I'm sort of stepping away because Tolas has a...
Yeah, I'm trying to sneak through without the stupid application and phone, and so consider myself the button to be clicked. Sorry about that. No, I mean, the way I was joining the original effort, which unfortunately due to the main authors failed, was that I felt that this was back then the best option to promote the new multicast model that BIER gives, by being able for the sender to indicate the explicit set of receivers for every individual packet. And we haven't really leveraged on that opportunity yet. And so maybe it is a good thing that we can try to broaden the scope of explaining exactly that functionality to find more interest in BIER, and the fact that we're forwarding through sender-defined bits to receivers, right? So that would be my very ad hoc bad sales pitch, and I'll try to join the effort by some appropriate word on some other use cases. So I'm not quite sure how to structure the whole thing, but if you want to sell the BIER idea to more applications, then maybe join the effort and we'll try to figure out how to structure it.
Okay, so input from my side will be focused on basically requirements. What problem do you try to solve? So we don't end up in the generic reliable multicast problem, which is one of the famous,
Totally not. You're completely agreed, and that's exactly what I mean with use cases in terms of what is the stuff that we can do better with BIER than with the native multicast.
Yeah, I mean the HTTP looks excellent. Right? Yeah. The HTTP stuff looked excellent, as a use case. Yeah, thanks. Sandy, you have the mic.
Hello? Hello?
We hear you.
Oh, okay. Just comments for the previous slides.
Oh.
I read the beer HTTP draft before, and I think that this draft is using beer as multicast underlay, so the HTTP service can be distributed by multicast way. I think it's very interesting, and I will follow the processing of the draft. Okay, thank you.
Yeah, so join the draft and work with Toles and the author on specifying what problem do you really try to address, because it seems, to be more generic than before. I know, and before we can even go and start to maybe to ADs or, talk about what will be scope of work like that, we need a problem definition, right? Practical use case is fine, but really what is the scope of something like this? Thank you.
Okay, we're moving to next presentation, the RH.
For it, right. But for now, I see nothing. Beer is not extended for it, but it's very interesting use case.
Yeah, no, it will be purely overlay on top of beer. Yes, thanks.
Yeah.
Okay, so we are done with comments, and we are moving to the next presentation, which is the routing header. It's either Y or Ajun presenting.
Hi everyone. I'm Wei Wang from China Telecom, and I will
Could you
give
please try to talk a bit louder?
Oh, okay.
Oh.
Hello?
Hello?
Hey. So I will give a presentation for our draft, routing header based beer information encapsulation. Next slide, please. This presentation includes 4 parts. The considerations for beer information encapsulation in layer 3 header, the format of beer routing header, the multicast packet forwarding procedures, and the further actions of this draft. Next slide, please. The MSR design consideration draft proposed the following requirements for beer in IPv6. It should support the basic multicast functionalities and meet the needs of high-quality services with high reliability. Besides the above requirements, we have additional considerations. We hope the source and destination addresses can be preserved along the forwarding path, because the operators need to count and monitor the multicast traffic, and the current technologies are based on the source or destination address. We also hope the identification of VPN traffic should be based on the destination address. The existing beer encapsulations cannot meet the above demands, so we think it is time to define a new beer encapsulation method. Next slide, please. Considering the above requirements, we think use routing header to carry beer information has the following advantages. It aligned with the usage of routing header. The T and B can be realized in a unified way, and the previous requirements can be met. So we defined a new type of routing header to carry beer information. Next slide, please. The format of a newly defined routing header type is shown in the figure. We need to define a new routing type. The 8 bits follow the routing type field indicates the BRT algorithm used for the RHB beer packet, and the encoding format of the following BRT algorithm specified part depends on the value of BRT algo field. Next slide, please. This scenario shows the forwarding procedures when all nodes in beer domain support beer routing header. Node A is a BFIR. When it receives a multicast packet, it will encapsulate an IPv6 header with beer routing header. Then it checks whether there is BIFT corresponding to the BIFT ID locally. If not, discarding the packet, otherwise performing the normal beer forwarding. The same forwarding procedures also perform on node D to F. During the forwarding path, the source and destination address in the IPv6 header are not changed. Only the bit string in beer routing header is updated. Next slide, please. This scenario shows the forwarding procedures when some nodes in beer domain do not support beer routing header. Node A encapsulates an IPv6 header with beer routing header to the packet and forwards the packet to node D according to the BIFT. Sorry?
You are very quiet again. Something with your microphone. Please check.
Oh, can you hear me now?
Yeah, this is
Much better.
Thank you.
Oh, okay. And Node A encapsulates an IPv6 header with beer routing header to the packet and forwards the packet to Node D according to the BIFT. Because Node C doesn't support beer routing header, so Node D should calculate the IPv6 address of E and encapsulates an outer IPv6 header to the packet. The source IPv6 address is the address of itself, and the destination IPv6 address is the IPv6 address of node E. Then it sends the packet to node C. Node C performs normal IPv6 forwarding according to the outer IPv6 header and sends the packet to node E. Node E decapsulates the outer IPv6 header and forwards the packet according to the BIFT. In this procedures, the source and destination address in the inner IPv6 header keep unchanged. Next slide, please. Our next steps are listed here. We plan to extend the solution to carry VPN-related information in multicast destination address, including the generation and transmission of the address and the behaviors on devices to handle it. That's all for the presentation. Your comments and suggestions are always welcome. Thanks.
Ngong, please go ahead.
considering solutions to encode beer in IPv6 extensions header. So I don't know why this is listed in the agenda. I think this question is to chairs. Thank you.
Sorry, what is the question to chairs? What is the specific question?
I think you got cut somewhere in between. Could you please repeat your question? We cannot hear you.
Okay, let's move to the next person on the mic, please. Bring her on.
Hello, can you hear me?
Yep.
Okay. I think I have the similar question with Fan Hong. My question is to the chairs. The working group had concluded not to work on solutions to encode beer in IPv6 extension header. After I think about more than 3 years of discussions. So I don't understand why this routing head beer draft is listed in the agenda for discussion. Is the working group changing the conclusion?
No, but I mean, they asked for a presentation slot. It's up to us to let things present. Frankly, I'm lost as well. There were no updates to the draft. I think the process ran its course all the way to the bitter end of formal complaint against the chairs. But you know, if presentation slots are requested, we're perfectly fine to see something, especially if there's any new work, which I didn't see here, frankly. Satisfactory. Thanks.
Hello?
Yes, please go ahead. We can hear you.
Hello?
Yep. Just
Hello,
go ahead.
Anything?
We cannot hear you now.
Okay. Hello?
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 Yes, please go ahead. John, go ahead. Please speak up.
So I think I want to answer the question on the list or on the chat, okay?
Okay. Okay, it's Jeffrey again on the...
Okay, so this is basically the slides are to help discussing the beer extension headers. Next slide, please. Some background. There have been several drafts related to beer that start talking about beer extension headers. The first one is this generic delivery functions, we call it GDF. We put out a couple of years ago, first in the Npos area, a working group. Basically, we noticed that there are several functions that are currently defined for IP, but they are actually applicable for other layers as well. One example is fragmentation. Another one is security. And so we thought that it would be nice to be able to extract that out and apply it at different layers, be it Npos, IPv6, beer, or Ethernet, if they want to do so. So we wrote that GDF draft, and we discussed it in Npos working group. At that time, I also noticed that the IOAM work started there, right, and the IPv6. This is actually also one of the functions that can be considered as generic. So later on, when I was working on a draft about beer support for network slicing, and in one case, I would need to encapsulate some other information about a slice or even more granular information that would need to be put into a extension header. So for that, I brought it to beer working group as well. In the last IETF meeting, I referred to it in a slide and talked about it briefly. But I have not got a chance to actively drive the discussion in the beer working group, even though I said, yes, this when it comes to beer, we need to discuss it in beer, but I had not done so. Then just last week, I noticed this the beer IOM drafts where we're talking about the beer extension header as one of the options to encode the IOM information. So now it's clear that it's time to actively discuss how we do the beer extension headers. Back to Npos, it has a design team to look at Npos extension headers, and there is this draft song talking about extension headers. I think both Tianran and I are co-authors of that draft. So when it comes to the GDF, we wanted to align the beer and Npos extensions. Basically, we define one extension header mechanism that will be applicable to both beer and Npos. Next slide, please. So this is the Npos extension header format. At the top is the regular Npos label stack. There is some sort of indicator saying that at the bottom of the label stack, there is an Npos extension header. The first 4 octets of the extension header is like a header of headers, and including the number of extension headers and total length of the extension headers, original upper layer protocol, and then the next header that points to the next header, the real header. Here we have two examples, extension header H1 and HN. So the next header field will allow you to traverse all those extension headers. So now, currently the next header value is actually taken from the IP protocol numbers registry. But in order for us not to use too many values for Npos purposes, then we say that one of the next header value will allow us to say that we'll have subtype so that we can further distinguish which are the Npos or specific ones. So that's the basic idea. One thing I want to point out is that you can see that if you exclude the header of headers part, it's very similar to IPv6, with one difference that the header length in Npos case is in the 4 octet units, but IPv6 header length is in the 8 octet units. That's one difference. Next slide, please. So now we wanted to apply this to the same to beer. So then the beer header would have a proto value to indicate that there is a beer extension header follows, just like the Npos label stack have an indication. We talk about the NH value taken from the registry. So now, going back to the generic function, the idea is that some functions that can be applied at many different layers, we want to be able to reuse the same encoding, and therefore we can do it the same hardware processing. So if you consider that for a real generic function, it will be applicable to IPv6 as well. So ideally, we would want to be able to just reuse the IPv6 extension. For a particular function, if there is IPv6 extension header defined, we would want to be able to use it as is for Npos or for BIER. But the header length in the for Arctic units prevents us from doing that. Next slide, please. So for BIER, here are the questions I want to discuss in a working group. We don't have to have any conclusions here. I just want to point this out. We can follow up on the mailing list. So first of all, does this make sense to BIER? Do we want to align the extension header formats encoding between BIER and Npos, and even with IPv6? And in the IOM case, do we want to use this format for BIER IOM if the BIER IOM goes ahead? Do we want to align with Npos, or do we want to align with IPv6 as well? There actually, so one simple way will align with IPv6 is that simply change that header length from the 4 octet units to 8 octet units. That would work out easily. I guess the concern why they wanted to do 4 octet units in Npos case is because it's more granular. For us, which way do we want to go? And also, actually, just before this meeting, I was thinking of another way to allow that 4 octet units normally, but still we have another container to put all the IPv6 extension headers in. So I just want to throw out these questions, and then we can discuss here and discuss in the mailing list. I want to point out that it seems that in the BIER LM draft, it's also just seem to be putting the IPv6 header directly after BIER header. So we maybe already aligned somewhat. It's just that if we want to do BIER extension header, let's look at it in a holistic way and make sure that we consider all the use cases and make sure that we are doing it in a good way, and ideally generic way aligned up with other extension headers as well. So that's it.
So Jeffrey, I admit frankly to be lost. Are we talking about GDFing BIER, or are we talking to extend BIER to have an extension header?
It's really to have BIER extension headers. Well, GDF, to do GDF, we will need extension headers, right?
Okay, got you. Okay, so do you have some packet format suggestion? What we would need to do?
Yes. Can you go back to that?
Sorry, I was on the chat.
Yeah.
Okay. Yeah. Here we go. Sorry. Yeah. Mm-hmm.
Yeah. So ideally, we would want to align BIER, Npos, and even IPv6 extension headers. Same format. That way, any function that is generic that can be applied at IPv6 or Npos or BIER level, we just use the same encoding. That way, the hardware implementation can be reusable.
I pass. I have to read the draft. Your draft in excruciating details. I'm a little bit lost. What is coming after what here? Okay. Questions?
No problem.
I follow precisely the original GDF, but that looks like another serious ref. Thank you.
Oh, this is one way to do the GDF. Yes, this is the one way to do the GDF. Proposed way to do the GDF from me. Yeah.
So I don't see any comments nor hands. We would have to take it to the list.
Sure. Many want to stir up this discussion. Yeah.
Yeah. So I think it would be great if you would send an email to the list with a pointer to the presentation and start the discussion. Alvaro, you were going to say something? Oh, okay. Then I think we are done for IETF113. Hope to see all of you in Philadelphia. And great to see you.
Thanks everyone. Till next time.
Bye, everyone. What are you talking about? Carlos Pima saw yesterday.
Maybe I'm just still confused, out of air, brain under mask.
So I'm not sure if you, as a delegate, can see the slide that comes out of the group.
Oh, right. That is interesting. So let me see.
I have no idea.
Yeah. This is a completely new feature for me. So, because I was just trying to propose my slides, and I don't, of course, see the propose button anymore. Drafts. So I don't see the propose button anymore. And there's only the agenda. What is that?
So, but you have the upload slides button.
Yeah.
So
I
I guess your view is the same as chair.
For some habits, you may need means that your head is always funding that.
Are there were any that have
Anything
had been approved, then yes. I don't know if people are putting the slides there.
It's Wednesday, and I've got all the slides for my Harvard colleagues. It's so good. So you can see that. Did they also ask you for this? Supposedly there's a deadline.
Like even if it's there, well, again,
Yeah.
they check. But I guess the extension letter will come after a year.
Oh, darn.
Oh, come on. So that's okay, because then you make it optional, like the hardware can't do it.
Yeah. I don't stay around.
Yeah, there are some older hardware, like even on our site, that is not going to be able to load the 25, 56 bits and then the extension header. Okay, that makes sense. All right, cool. Thanks.
Want to grab a coffee? Sure. I really like that.